Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. We've seen that interaction terms allow slopes to differ across groups, so now let's work through a concrete example and interpret everything step by step. Let's suppose that we are starting from a regression that looks like this. Y being equal to 1000 plus 50x plus 200d and then 30x times d. Okay, so Y as usual is monthly income, X is years of education, and D is equal to 1 if employed. Okay, so let's write the two group equations case by case like we've always done. In this first case, we're going to have D being equal to 0. So keep in mind, we're working with the unemployed subsample here. In this case, our Y hat is going to be simply 1000, it's like here, plus 50x, because these two terms in here that have the D are going to simply cancel at 0. So that means that our intercept in here is the 1000 and then the slope is the 50 because the 50 is what is attached to the x. Case 2, when D is equal to 1, meaning we're looking at the employed subsample, we're going to have Y hat being equal to now 1000 plus 50x plus 200 plus 30x. And we're going to put together the likewise terms. So we've got a 1000 and a 200 that don't have an x attached to it, and then 50x and 30x, which means that we can rewrite this as 1200 plus 80x. So look here, now the intercept of this case is 1200, while the slope is now 80, okay? So we can very clearly see that the returns to education, because remember, X was education, the returns to education is 50 for the unemployed and 80 for the employed, okay? Which means that the difference, so this shift, the difference in slopes is 30. And 30 is exactly the intercept, sorry, the beta that you had in front of the interaction term. Okay, so the beta 3 is shifting the slope by 30. And here, by analogy, we have that, well, the same way that the 30 here is shifting my slope, this 200 in here, it's what is shifting my intercept. So the change here of 1000 to 2000. Okay, so in another way, you can also say that the return to education like changes depending on the group that you have. Okay, so education increases income more for employed individuals, and that is by 30 per years of education. Okay, so education increases income more for employed individuals by 30 per year of education, because remember here this X was education in years. Okay, so the extra beta 3 is basically the extra return on education for the employed group. Now, what if you wanted to compute predicted values? Let's see that with an actual example. So imagine, assume that X is actually equal to 10, which means we've got 10 years of education. We're going to use the same information that we have in here. So for 10 years of education, in case 1, the predicted Y, so for the unemployed people, it's simply 1,000 plus 50 times 10, which would give us simply 1,500. Instead, for the employed, we're going to have a predicted value, Y1, of 1,200 plus 80 times 10, which would give us a total of 2,000. Okay, so the difference overall in predicted income for someone who is employed versus someone who is unemployed, keeping constant the years of education at 10, is actually 500. Okay? Now, this gap that we see in this case depends on X. Okay? So we can do exactly the same computation, but let's say we fix now years of education at exactly 5. So what's going to happen is that if we do the same calculations, now here we're going to have 1,000 plus 50 times 5, which is going to give us a total of 1,250. And for Y1 here, we would have 1,200 plus 80 times 5, which would give us a total of 1,600. So the gap in here, the difference now in Y hat is actually 350. So look carefully. What that is telling us is that actually the gap between groups, depends or increases in this case with education. Okay? And how exactly, like, what's the math in here? Well, you can very clearly see that when we are switching from 10 years to 5 years in here, in the first group, the only thing that is changing is actually what is multiplying the 50. So in here, 50 is multiplied by 10, here is multiplied by 5. Okay, so even the predicted value, if we look just within the same group, depends on that slope that we have in front of the x. Okay, so the gap grew exactly by 150. Okay, which is exactly our beta here, in this case, in front of the x. And if we generalize it for the other group as well, would be basically what's in front of your beta 3. So beta 3 times any of the changes that we have in x. If you concentrate only on the first group, it's just going to be beta 1 instead times any changes in x, because beta 1 is the only thing. Okay, so just within the group. However, if we look at across groups, that's going to be the beta 3 times the changes that are happening in your x, which is, in this case, simply the 30 times the 5. And this is not a coincidence, okay? Because if you remember, when we found the derivative of y with respect to the dummy, that was simply beta 2 plus beta 3 times the x. So in this case, we have all the numbers. This should be just 200 plus 30x. So the difference across the two groups now, it's literally just that beta 3, which in our case in here is the 30. Okay? You can do the computations in here, like now using this formula, you can try x equal to 5 and x equal to 10. You will find out that in this particular case, you're going to find for x equals to 5, a value of 350, and for 10, a value of 500. And the difference in here is going to be all over again that 150. So again, the numbers will agree perfectly to the formula. There's nothing new that we're adding in here. It's just another way of showing exactly the same thing. So the big takeaway out of these exercise should be that, well, interaction terms allow both the slope to differ across the groups and the group differences to change with x. And these are two sides of the same coin. I hope this was helpful, and I'll see you in the next video.